free vibration, you can observe here the spring is attached with the support and a mass is being attached here. So due to this mass, what happens? The object automatically vibrates. So without any external force, if you pull it once, it vibrates again and again. This is called free vibration. And the example for forced vibration is a string. When you are playing the guitar, every time you apply the force to a string, then it vibrates. So here dynamics connected with vibration. Each and every time you are applying a force and it is vibrating. This is called forced vibration. And next phenomena is stiffness. How you can understand stiffness is fine ceramic material. You will be having less bending. If you have metal and stainless steel, you will be having higher bending for the same load. This depends on stiffness. If you are using material, according to the material which you use for constructing, you can build structures by using wood or steel, concrete. So the structural characteristic differs. This is called stiffness. Stiffness formula I have discussed in last class, force required to cause unit deformation. So this is the definition. Force divided by deflection is called stiffness. Here the force is same. You can assume it as a 10 kg. If 10 kg of force your bending is very less, it could be 1 mm. And the same load if it is applied in a stainless steel, you can see large deflection around 20 mm. You can assume it is 20 times. Then what happens? One character changes, that is stiffness. So when you are building a structure to resist earthquake, your structure should be not very flexible. If your structure is flexible, what happens? Due to any force application, the structure starts oscillating too much and we do not like the structure to vibrate. So under an earthquake, our structure should be stable. So this is what our intention. For that, what you have to increase is the stiffness. If stiffness is increased, the bending will be reduced. Next thing is natural frequency. If you have any stiffness here, see in this problem, there is a frame here and in that frame a beam is being connected. This beam is called a stiffener K and it is mathematically represented in this manner. Same way in structural analysis and analysis of indeterminate structure, instead of this beam, we would have only used a single line. If you have continuous beam, we would have used multiple single lines. So this is modeling of a structure. Similar way, the beam which we are using here, it's been modeled by using the dynamic system by this kind of a model. So you have a support here, the same way you have support. Only thing is the support is vertical, and if you tilt it vertically, if you have stiffener and a mass, so the mass is provided at the end. The same case here. What happens if you are applying a force? Here you understand this is not a free vibration. This is called forced vibration. Constantly the force is going down and up. Okay, when it is acting, you can plot this into a graph. How you can plot this? You take a graph and mark it as positive side and negative side. If it is going down, you can plot it downward, that is in negative direction. And if the mass is moving upward, you can plot it in positive direction. It constantly moves down and up. So down and up. You can plot in terms of frequency. This is the graph which represents frequency. This is known as time. X-axis is known as time and Y-axis you can take it as deformation. So when an object is oscillating, you can make the oscillation into a vibrating plot. So this is the vibrating plot of that. If you plot like this, why you need to plot the vibration? If you want to understand the character, if you are deflecting the mass up to 10 mm and you are releasing, what happens? The object keep on oscillates. You are interested to find at 5 seconds what will be my displacement. See, the object is static at a point, you are deflecting to 10 mm, it vibrates. So you need to find at 5 seconds what will be the displacement? You know that initially 10 mm will be there. If it is keep on oscillating, at one point of time it will come to rest. At 5 seconds of time, what is the displacement created? So you can find this. Okay, what is the purpose of finding this is during a high wind or during any earthquake is vibrating for 30 seconds. See, each and every earthquake will not persist for a constant period of time. Some earthquakes might long for 1 minute, some earthquake might long for 20 seconds, or some earthquake can long for 40 seconds. For finding that, you need to understand this. If your building oscillates for 1 minute, what will be the displacement? How much it will deflect? Okay, what are you going to do by finding this? You can rebuild your structure. According to the earthquake force, you can build your structure. So this is the purpose of that. Okay, in order to find that, you have to plot this kind of a graph. So when plotting this graph, this is displacement graph, you can find a parameter called natural frequency. What do you mean by natural frequency is, in last class I have discussed omega n equal to root of k by m, and another component is amplitude. What do you mean by amplitude? Here you can see the object oscillates into positive and negative direction. What is the maximum point? The second oscillation is the maximum point. So your amplitude is the maximum displacement or deformation of a vibrating system. Here in the first cycle you don't have amplitude, maximum amplitude, but in the second cycle you have maximum amplitude. So this is called amplitude. When an object oscillates, what is the peak of displacement? Is called amplitude. Okay. Now you want to understand resonance. What do you mean by resonance is, you can see there is a spring for three objects. The spring has same stiffness, that is K is 100, assume it as K 100 and 100, but the weight changes. What is the purpose of indicating the different color is, assume that the weight changes and you are creating a vibration at the base. Why only one system is been oscillating much higher is due to resonance. This is what I said. The earthquake is same for all the structure. If you are looking into our natural topography and our infrastructure, it is similar to this. Earth is vibrating into particular frequency and you have buildings of different height and different weight. So what happens, due to vibration, not all the building get collapsed, only the building catches the resonance. It vibrates and oscillates high. You need to find in the design stage, what do you mean by resonance is, when the frequency of external force, what is the external force is earthquake. So assume this as the external force, and when it equals or matches with the one of natural frequency. How will you find natural frequency for this? If you have any system, what is the formula? Root of K by M. You have stiffness here, K, and you have mass here. You can divide it and find natural frequency. If you find natural frequency, earthquake frequency will be there. If you divide this, answer should not be 1. If it is 1, this kind of high oscillation will be there and your building will be subjected to collapse. So in the earlier stage, you have to find that resonance has to be founded and the amplitude of vibration becomes excessively large. This phenomena is called resonance. Okay. Next, understanding what do you mean by fundamental mode of vibration. If any vibration is occurring in a building, imagine our college building, it is having 7-story structure. Each and every floor has a mass. 7 number of masses are there. You imagine this as the building, where in this case the building has 4 number of floors. Now, what do you mean by fundamental mode of vibration is, you know to find natural frequency. For each and every floor you have to find natural frequency, and after finding that, what do you mean by T? We have discussed in last class. T is known as time period. How will you find time period? Inverse of natural frequency, 1 by F. it is known as time period. In the fundamental mode of vibration of structure, which is having the lowest frequency, you can find the frequency for each and every system. System having least mode of vibration and frequency is called fundamental mode of vibration. If you have 4 number of floors and it is vibrating in only one direction, you will be having 4 number of mode shape. If you are having 2 number of floors and applying force in one direction, you will be having 2 mode shape. If one mass is there, you will be having only one mode shape. Since you have 4 floors, 1, 2, 3, 4, you will be having 1, 2, 3, 4 mode shapes. Next concept is damping. What do you mean by damping? It's a resistance to motion of a vibrating body. What is resisting? Here you can see a clock. This is what I have said in last class. If you tap the pendulum here, it will be keep on oscillating. The dampness will be very less at the point here. It is been connected with the center point here and the dampness is very less. Imagine that you are having same kind of vibration here. You have a mass and a spring is attached here. Now this is attached with the water. You vibrate the object. What will happen? Due to this water, the vibration seconds will get reduced. Now you remove this water jar and you try the experiment, oscillate for more duration of time. And if you introduce this kind of water, what happens? The vibration is going to get reduced. So if it is longing for 3 seconds, if you remove the vessel, it will long for 30 seconds. So what is changed is the dampness is changed. If you increase the damping, your system will not vibrate. During any earthquake, your building should not vibrate more. In the sense, what you have to introduce? Dampness. If you are introducing dampness, your building will not vibrate too much far or too much long. Here the dampness is very less in case of the wall clock. Hence it is keep on oscillating. Next you take down free vibration of single degree of freedom system. Now we are going to take a single component called a frame. Only one frame we are going to take. You have 2 number of columns and mass is being located at the center. This mass is taken as a lump mass. All the masses are concentrated at a single point. You are having 2 support which is fixed. Now how to solve dynamically? So in analysis of determinate structure and indeterminate structure, you will be taking all the beam into a line and how many supports are there? You will be identifying it as partially hinged support. All the intermediate are partially hinged and at the end support you will be taking it as fixed. This is for static analysis. But for dynamic analysis, this is your structure. You have to write it like this. This is called modeling. How this is modeled is, this end is fixed, hence you are applying fixity here. How many columns is here? You have 2 number of columns. Column has to be taken and assumed only as stiffener. Column is not carrying any vertical load. Now you have to imagine differently. For static load, your load was vertical. All the floor load was acting vertical. Now earthquake is a horizontal load. Now we are not interested in vertical load, we are only interested in horizontal load. That is why the load is given horizontally. If load is horizontal, your structure is not going to bend in this manner. If you are giving a load vertically, your structure will bend and buckle. Now earthquake is a horizontal force. Your structure is not going to buckle now, it is going to deflect. So what parameter is required is stiffness is required. Stiffness is what I have explained in previous slide. Stiffness is force required to cause unit deflection, F by delta. So if horizontal force is acting, your structure is going to deflect and it is going to take only stiffness parameter. That is why column is being taken as K here. Your both the columns are added as a single column and only K is written here. Now, you have mass on the beam. That mass is being assumed as M here. This is called modeling. If any building is given, you should know to model. If you model like this, and what is this X in the sense? This system is vibrating in one direction. What is the direction? Here the force is given, this frame is going to oscillate in only one direction. Spring mass system is being drawn here. Now you are going to find the equation of motion. Now what you are interested is, we will be drawing free body diagram. How to write the free body diagram? After removing all the external forces, only the mass will be there, and whatever it is connected, you will be indicating it as force. Now, if I am trying to pull this mass here, will this stiffness allow? No, it will not allow. Why? Because it is catched. You imagine that it is catched in a thread. This will not allow, hence K will be in opposite direction. Now, if I am trying to pull this now, mass, if you increase mass, could you pull it easily? No. Mass is also opposite to the direction of motion. If mass is higher, you have opposite motion. That is why M is written in opposite direction. So, if I need to pull in right side, what are the two resisting force? One is mass, another one is stiffness. These two parameters will not allow the object to move. So, this is known as the free body diagram. Now, if I do not want my structure to even vibrate, then I have to satisfy this equation. If external displacement equals mass and stiffness, your building will not vibrate. So this is how you are going to match the science with the construction. If your external force and internal force, that is motion and the resistance is equal, your building is not going to get vibrated. Okay. Now I write in terms of an equation. M x double dot. What is this x double dot? Is acceleration. X is displacement, x dot is known as velocity, x double dot is known as acceleration. Now M x double dot, you have to write mass component in terms of x double dot. Why? What is called force? Force is known as mass by acceleration due to gravity. Force equal to M into x double dot. This is mass force and this is stiffness force. What is stiffness? K equal to F by delta. Now if you want to find F, you can cross multiply the delta. What is delta? Displacement. Displacement is x. So you can cross multiply x. So stiffness force is known as K into x. Okay. This is the equation. If the force is acting left hand side, you can write it as negative. If the force is acting right hand side, you can write it as positive. Now both the force are acting at left hand side. Minus mx double dot minus kx. Now I can take negative outside. It will become mx double dot plus kx. Now if I can divide this, I am dividing the whole parameter by m. If I divide this by m, what will happen? M and m will get cancelled, and if I divide k by m, it will become this parameter. Now if you need the frequency, how you can find is frequency square is equal to k by m. When you are writing this as x double dot plus omega square into x equal to 0. If you take the square outside, you will be getting k by m. Equation of motion for free vibration of single degree of freedom system. By this single equation, you can find if your structure is vibrating 3 seconds, what will be the displacement. If your structure is vibrating 10 seconds, what is the displacement? You can find all the parameter by using this general solution. X equal to x naught. What do you mean by x? You write it where x equal to displacement, x dot equal to velocity, and x double dot equal to acceleration. Now can you understand what is this equation? X is displacement. So displacement equal to what is X naught is initial displacement. Naught is called initial displacement. Initial displacement into cos omega n. How will you find omega n? Root of k by m into t. What do you mean by t is called time. If any object is oscillating at 20 seconds, you have to find the displacement is, you have to substitute here as 20. So at both the equation you have to find it as 20. Now what is x naught dot? What is x dot? Velocity. What is naught is initial velocity. So initial velocity by omega n sin omega n t. This is important equation in order to find the displacement of a free vibrating object. Parameter here is x max. What do you mean by x max? Maximum displacement. X naught is called initial displacement. X max is called maximum displacement. This is called amplitude. Velocity x dot max. How to find x dot max is a, that is amplitude into omega n. And if you need to find acceleration, x double dot. What do you mean by x double dot is called acceleration. X double dot max is maximum acceleration equal to amplitude into omega square. These formulas are very much essential to solve problems. By using this formula, you can solve number of problems which is asked in this module. T equal to time period. Second is the unit of time period. And 1 by f. What do you mean by f? Frequency. The unit of frequency is radian per second or hertz. These are the two units. K equal to W by delta. What is K? Is called stiffness. Formula for stiffness is force by deflection. What is the unit for force? Newton. What is the unit for deflection? Meter or millimeter. So your stiffness unit is Newton per meter. W is called force. Delta is called deflection. So your stiffness formula is force by deflection and its unit is Newton per meter. Now write the third formula as omega n. Omega n, what is n? Natural. Omega is frequency. Natural frequency. How to find that? 2 pi into f. What is f? Frequency. If you multiply frequency into 2 pi, you will get what? Omega n. Natural frequency you will get. So write omega n equal to natural frequency. What is the unit of natural frequency? Radian per second. A stands for amplitude. Unit of amplitude is meter. Initial displacement. What is x dot naught? Initial velocity divided by omega n. Pi is known as phase angle. The unit is in terms of degree. Tan inverse of x dot naught divided by x naught omega n. You know omega n is natural frequency, is root of k by m. K is stiffness, m is mass. If your building is having two number of columns and you have a beam that is carrying a mass, then your system will be like this. Two columns is here and one mass is there. It has to be written like this. This is stiffness 1 and stiffness 2. How to add it? K can be found out by force by deflection. If you add K1 and K2, you will be getting effective K. You can add two columns and make it as one by using this formula. If it is connected parallelly, series is one column above the other is called series, and if you have column in parallel direction is called parallel connection. If your column is parallel, you can add that. If your column is series, what you have to do? You have to find 1 by K. That is the difference. How to find effective stiffness is E stands for effective. The effective stiffness is 1 by K1 plus 1 by K2 equal to 1 by K effective.